In this problem, we're going to be looking at the combustion reaction between C3H8, which is actually propane, and oxygen. Okay? Combustion reaction means reaction with oxygen. And in a combustion reaction, especially a complete combustion reaction, we're going to produce only carbon dioxide and water. Now, combustion doesn't always occur that way. There are some types of side products that we might observe. But for the most part, when we talk about combustion, this is what we're going to be talking about. The reaction with oxygen to produce carbon dioxide and water. So, when we're balancing a chemical equation, we're going to do a lot of counting. Okay? And in particular, we're going to be counting how many atoms are on each side of the chemical equation. And what we want to know is the stoichiometric ratio between all those products and all those reactants. Now, the way I start these problems that I've talked about with you before is with the idea that I'm going to look at which of the chemical compounds is the most complicated. And in particular, what I'm really going for is which one of the products or the reactants would have the most atoms in it. That's generally what I'm looking for. And so if I look, the C3H8 is going to be it. And that's where I'm going to start. And I'm going to put a coefficient of 1 smack dab in front of that C3H8. And so when I do that, now I'm going to go ahead and say, okay, I don't have coefficients here, here, here yet. They're going to end up there, but they're not there yet. And so I'm going to take only the things with coefficients and calculate how many atoms I have. So the carbon and the hydrogen on the left-hand side of the equation all comes from that propane molecule. So I'm going to say then there's one of those, so there are going to be 3 carbon atoms, and there are going to be 8 hydrogen atoms on the left-hand side. Now, in order for a chemical equation to be balanced, I have to have the same number and the same type of atoms on both sides of the equation. Remember that we have to have that same number on both sides for the reaction to be valid. And remember that one atom can't change into another. So a carbon atom doesn't change into a nitrogen atom. It just doesn't happen. There are particular types of nitrogen or of particular types of nuclear reactions that, in which case the identity of an atom can change. But that's going to be something you won't cover or you won't see until the very end of Chemistry 111. We're not going to worry about that right now with balancing. So we've got 3 carbon and 8 hydrogens on the left-hand side of the reaction arrow. I'm going to put a little line here just to keep the 2 separate. And so now I'm going to go, just take the carbon for instance, and I'm going to say, okay, there are 3 carbon, and I'm going to go and I'm going to look and see which molecule on the right-hand side has carbon in it. If it's in multiple different compounds, then we're just going to sort of leave it alone. It will work itself out. And in particular, I'm going to talk about oxygen. Oxygen's in 1, 2, 3 different compounds. We're going to leave it alone. It will work itself out as long as we balance everything else. But carbon, however, we've got 3 on the left-hand side, and it's only in one of these compounds. It's only in the carbon dioxide, so we can go ahead and balance it. So we have 3 on the left. We need to make sure we have 3 on the right. There's 1 of them in each carbon dioxide. So I'm going to put a 3 there. And when I do, I'm going to multiply 3 to give me that the 3 carbon atoms on the right-hand side. So I've now balanced this chemical equation for the carbon atoms. Okay, we're good there. How about hydrogen? Hydrogen's here in propane. And it's also here in water. That's the only source. I've got 8 here. I need to make sure there are 8 on the right-hand side. So they come in groups of 2. What times 2 will give me 8? Well, it's 4. So 4 times 2 will give me 8 hydrogens. Now I've got both of those balanced. The only thing left is the oxygen. I'm going to write OXYGEN just so that you don't think it's a 0. So now, I've balanced both of these molecules on the right. I'm just going to calculate how many oxygen atoms I now have. So 3 times 2 is 6, plus 4 times 1 is 4. 6 plus 4 is 10 oxygen atoms. Now I'm going to come back I've got oxygen all by itself here. It actually makes it fairly simple. What do I need to multiply 2 times to get 10? How many oxygen molecules, which contain 2 oxygen atoms, do I need to get those 10? Well, 5. 5 times 2 will give me 10 oxygen atoms. Same number, same type of atom on both sides of the equation. That's how I know that my chemical reaction is balanced.